Probably still might look right. So it's his head. One more. Oh yeah. That's what I'm watching. The comments will I try to comment.
Oh, where's my cat? Upset.
Oh, it's probably don't make it 18 plus. I think so. It's probably on.
I was first day of practice.
Fine.
That's a record. It's any questions on these roads?
What's
that?
I don't have any questions.
Oh, good. Bernie? Questions?
So we can really understand. We get the highest quality
Where's the rest of the, you got 358 on the first section.
Oh, I didn't. John, I just decided that I did not want to do it. So I mean, I'll do it tonight. Maybe for the answer.
Yeah, the US.
Washington is like not.
Blackton?
Yes,
Mr. Stadoulis is in here the period before. I don't know what he did with it. Let's take a look.
I will go find him. Thank
Okay,
you.
yep. You said that,
Yes, there.
No, you didn't. All right, keep that homework available. Like I said, I didn't get to check it on the computer, so I'm gonna come by and just do it old-fashioned way. But any huge questions on any of these here before we move forward? Okay, looking at the test, I don't see any reason why I can't let you use the red calculator, so I'll have those available. If you got one of your own, that's fine. I don't think it'll affect, showing what you need to show. So we will allow that. I'll have those available. That will be tomorrow. Okay, there's no calculator test. All right, this front side of this page is like all calculator type problems. So take a look at those four not multiple choice, true, false. Take a look at those and see what you come up with. Okay, for those first four. 3 out of 4. 3 out of 4. I get you in the start straight.
That's the goal.
You ready? You ready? Okay. All right. Adam Libby, what you got back there for the first one?
I said false. I thought it was only 3 turning points.
That's what you thought, huh? All right, you're correct. It's false. And one thing is, if it's supposed to be n-1. What if you forget? Well, draw something with 4 turning points. Okay, 1, 2, 3, 4. So I draw something with 4 turning points. Can that be 4th degree? No. Okay, so draw things out if you're confused. Nathan Moore, how about number 2? The graph of 50-degree function can have no x-intercepts.
True.
True. That is obviously false. Okay. 50-degree function will always have at least one. Now let's take a look at y. Y. So if it's 5th degree, okay, like this one would be 5th degree. But any odd degree function opens up in opposite directions, right? So if it opens up in opposite directions, it has to cross the y-axis. Okay, it has to cross, or not the y-axis, the x-axis at some point. So that means it has to have at least one. Can an even degree function have no x-intercepts? Yes. Emily, how about number 3?
I said true.
You said true. That is true. Okay, it does. It can have one local max and one local min. Okay, so you could have like double roots or whatever. You say, well, that's 3rd degree. Well, yes, it can be 3rd degree, but it can also be 5th degree. It's open in opposite directions. You can have one max and one min. Okay, Tony, how about 4?
I said true.
You said true. False. False. Now, why is this false? Take a look at this. 4th degree function. You have to have 4 roots. 4 roots. What about complex roots? They always come in what? 2s. They always come in pairs. So if it has a complex root, it has to have another complex root. So a multiplicity of 2, that's 2 degrees. Multiplicity of 1, that's 3 degrees. And then a complex root means there has to be 2 complex roots, which makes it 4 5th degree. Okay, so false, true, false on those. Got it? Now, okay, find the zeros for you. This is on the calculator part of the test. So what do? You immediately graph it. Okay, this is the calculator part of the test. Full double graph. Somebody made a mistake. Yes, go ahead and graph that. Graph that. And see where it hits the axis. Okay. Tyler, where does it hit the x-axis at? Okay, I'll wait. I'm in no hurry.
1.
Oh, you got it's dead. 1. How many times does it hit it there? Well, does it bounce or go through?
Bounce.
It bounces. So what do we do? Mia, what do I need to do?
You said right out the equation.
Well, find the zeros. I need to list all the roots, all the x-intercepts, all the answers that make this equal to 0. So it hits at 1, but how do I find it? I got to find 4 of them because it's 4th degree. So use synthetic division. So it hits at 1, so go ahead and do synthetic division. And I got 1, -6, 14, -14, and 5. And then I get -5, 9, -5, 0. Okay, now here's the deal. It hit twice. It bounced. It means it has a root of multiplicity 2. That means you have to use 1 again. Okay, only since it bounced. So I use 1 again with 1, -5, 9, -5. And I get 0, 1, -4, -4, 5, 5, 0. So here's where we're at. I got x minus 1 times x minus 1 times x squared minus 4x plus 5. Okay, so now you got two roots. One counts twice. You got to use quadratic formula on the last one. Okay. And since it only hit twice, when you look at that graph, that tells you you've got to have complex roots. Okay, you got to have complex roots. And then, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. 4 plus or minus negative 4 squared minus 4 times 1 times 5 over 2 times 1, which is 2. All right, what do we end up with underneath the radical? Is it negative 4? Okay, so we get a square root of negative 4. And over 2, so I get 4 plus or minus 2i over 2. And so now in the end, my answers are 1. That will reduce to, let me put it over here. 1, no, not 1, 2 plus or minus I. 2 plus or minus I. We got 1, a 1, a 2 plus I, 2 minus I.
When we're on the test, will we need to write 1 twice?
Well, yeah, because you're going to indicate all 4 roots, just to be on the safe side, because it's a 4th degree function. There are 4 roots. We would list that one twice, counting multiplicity. Okay. All right, so if that's on the calculator portion, immediately go, you graph it, you find that somebody won't graph it, and they'll go through all this, and they'll be there forever. Don't be that person. Okay, don't be that person. Go. Now it's going to go too far. There we go. All right. Find the equation of the polynomial of least possible degree with integer coefficients whose roots are negative 2 and 1 plus 2i. Now, I didn't leave you a ton of room on there. There's a little bit of multiplying to do, so write small. If 1 plus 2i is a root, what else has to be a root?
1 minus 2i.
1 minus 2i. So we also add in 1 minus 2i. All right, least degree would be 3rd degree. Okay, 3rd degree. So we're not going to have any roots of multiplicity 2, anything like that. Everything's multiplicity 1. So you got f of x equals, if negative 2 is a root, x plus 2 is a factor, x minus 1 plus 2i, x minus 1 minus 2i. Multiply those two together. Now, there's different ways that you can do that. Distribute your negative. And then you can just do the trinomial times a trinomial. I showed you earlier, another way to do those is if you group the x minus 1s and make it minus 2i, and I group x minus 1 and make it plus 2i, That's a difference of squares, which would then become x minus 1 squared minus 4i squared. You can do that way. But I'm going to go and multiply trinomial times trinomial. Okay, just do that. Like that was just a separate way. If you want to do it that way, you can. Otherwise, just ignore it. But I'm just going to take x times all of those and then worry about the x plus 2 later. I get x squared minus x plus, I'm going to write that as 2ix minus x plus 1 minus 2i minus 2ix plus 2i minus 4i squared. Now don't forget, I squared equals -1. Everything with an I should cancel, okay, except for the I squared, sorry. Everything with an I should cancel. Plus 2ix minus 2ix minus 2i plus 2i. So I get x squared minus 2x plus 1, all right, minus 4i squared. Well, I squared is -1, so this now becomes x squared minus 2x plus 5. Okay, -4 times -1 gives me plus 5. Don't forget we got this x plus 2. All right, and at this point, if you haven't already done so, multiply those two together. And so let's see here. What do I end up with? F of x equals x cubed minus 2x squared plus 5x plus 2x squared minus 4x plus 10. And then I get f of x equals x cubed. Minus 2x squared plus 2x squared add up to 0. They're gone. Plus 5x minus 4x looks like I just get plus x plus 10. Okay. Man. All right, so we good on that one? Josh, Mark, we good?
Yep.
All right, let's take a look at the next one. Oh, this is a good one. All right, so you got this piece of cardboard. Now, we did one similar to this before. You're definitely going to need a graphing calculator. This is on the graphing calculator part. We're going to cut out equal sides or equal squares off of each corner. Hold it up. You're going to get a nice little box. Volume equals length times width times height. And so here, I'm taking out x out of each corner. And let's say the original was 38 inches, and then what was it, 22? 22 by 38, 22. And 38 is that original. All right, Aaron Hess, what do you think the height is?
the height is X.
The height will be X. Okay, good. Height will be X, whatever we cut out of that. All right, Aubrey, what do you think the length will be?
38 minus X.
You said minus X?
Yeah.
All right, you're gonna take an X off of here and here. 2X. 2X. So the distance, the new length will be 38 minus 2X. Paul DeLuca, how about the width?
22 minus 2.
22 minus 2X. So now here's what we got for our formula. Volume, whoops, let me write it out over here. So length, hold on, what am I doing? So length equals 38 minus 2X. Width equals 22 minus 2X. And our equation for the volume will now be, hold on, volume equals 38 minus 2X times 22 minus 2X times X. All right. Kayla, did you graph it yet?
No.
Good, don't. Stop. All right, what's the sketch of the graph going to look like? We'll graph it in a second, but what should the sketch of the graph look like? Where are the zeros? What's the degree? Okay, so I just want an overall idea what that graph should look like. Well, how do I find the zeros? Kayla, what do you think?
You make it equal to 0.
Say that again.
You make it equal to 0.
Make what equal to 0?
Length.
Okay, you take the length and you make that equal to 0. And you take the height, width, 22 minus 2X equals 0. And then the height, well, that's just X equals 0. I can do that one. All right, so you want to find the other two X's. So 38 minus 2X, well, that's 38 minus 38 equals 2X. X equals 19. 22 equals 2X. X equals 11. And we got 0. So it hits at 0. It hits at 11. And it hits at 19. Well, it's got to hit at all 3 points. All those are multiplicity 1. What's the overall degree? Third degree. And so now it is a positive. -2 times -2 is a positive 4. So it looks like this. Okay. All right. Anybody tell me what the only part we're really concerned about is on that graph? Okay.
Between 0 and 11.
Between 0 and 11. Because if I'm cutting out a corner and it's 22, you can't cut out more than 11. Okay. So the practical area of this, the practical piece of this graph is 0 to 11. Okay. Other than that, all this over here doesn't play a role in the practical part of the problem. All right, go ahead and graph it. See if you can get the whole thing on your window. See if you can get the whole thing on your window. You got it. Yeah. All right, what's the max you got? 6. Oh my God. It's amazing. Now, when you don't, for this problem, like across the test on a test, don't multiply all that out. Like I guess you could if you really wanted to, but absolutely, you don't have to. I think we're just going to have one test where all you do is change the window in your calculator to see the picture. Okay, we'll just do one of those. Well, what are you looking at? What did you, what did you hit? How did that happen? Sure. Got it? You're done? We need some, recharge some calculators. Okay, I'm only concerned between 0 and 19. Okay, so if I hit graph, like I got my equation in here, 38 minus, and I hit graph and I'm on 0 to 10, this is what it looks like, right? Nothing shows up. Not a thing. Because it gets too high too quick. Now, I'm going to graph the whole thing just to show you. But if you go to table, you know, when you plug in 2, I get 1,224. So that's a little bit above my 10. That's why you don't see anything. And so, again, and this is a popular ring. Blaine. Oh, Blaine.
I was skipping on LLP today.
There you go. Did you check your schedule?
I did.
Okay. All right, 1680 is the highest I see. That doesn't guarantee that one of those is the answer, but I got to at least be higher than that. So I'm going to go to my window. Now, I don't need to be way to negative 10. I'm going to go negative 5. I do want to see where 19 is, so I'm going to go to 25 just to kind of get the whole picture of the graph. I'm going to go up by 2, should be fine. All right, negative 10. Since I said the 2,000, I'm going to go negative 2,000, see what it gives me, to 2,000. And then I'm going to go up by 200 and graph. Let's see what that looks like. All right, so you get the whole picture. You see it's a third degree function. Some people get into the mistake of thinking I can use the fact, think of that's a vertex. That's not a vertex of a parabola. So you cannot use that little formula, negative b over 2a. Will not work. You got to go here. You got to hit second, calculate. And you got to hit maximum, which is number 4. And then on the left bound, I need to be to the left. And then to the right. And then in the middle. All right, I want everything rounded to the nearest hundredth. Okay, everything around the nearest hundredth. Yes. So that means my x is 4.49. And what's my y is 1696.50. Okay, so now what are the dimensions of the box? I want the length, width, and height. So take a second. I want the maximum volume. Maximum volume is that y value. But what's your length, what's your width, and what's your height? So maximum volume equals 1696.50. And so your height, we know, is just the x value. So your height is 4.49. Our length is 38. Our length is 38 minus 2x. So plug in 4.49 for that. Aaron, you got that?
The upper 38,
Yeah.
29.02.
29.02. And then the width is 22 minus 2x. Is that 13.02? Yes? 13.02. Okay, so there's your dimensions. And then your maximum volume is 1696.50. Okay, so in this case here, you gotta find the match. You can't just estimate for that. It's not a parabola. You cannot use negative b over 2a. It doesn't work. Okay, good there? All right, flip it over on the back. Now this one here is, this is no calculator part. I wanted to make sure, I knew we just covered it, so part of me was saying they should know, but then the other part was like, well, probably wouldn't hurt to cover one more. So, take a look, all right, and I kinda accidentally left up my asymptotes, make sure you agree with those. And then put those in for your vertical and your horizontal, then we'll kinda go from there. Peyton Burns, the vertical asymptotes make sense?
Yeah,
Does the horizontal asymptote make sense?
yeah.
Yeah? All right. How do we tell the horizontal asymptote?
You, both for this one, the degree of the top and the bottom are the same. So it's just like, you simplify it, so it's 2 over 1, so 2.
Yep, take your leading coefficients. Degrees are the same. Therefore, you just look at the coefficients. Mackenzie Ward, what if the degrees were different? What if the degree of the numerator was less than the degree of the denominator? What would be my horizontal asymptote?
0.
0, good, y equals 0. And so now we get y equals 2. Hopefully you're graphed in there. Madison, let's see, how do I find x-intercepts?
You set the numerator to 0?
Set the numerator equal to 0. So I want to take 2 times x minus 1 quantity squared and set it equal to 0. You can make this really easy or you can make this really hard. Because if you FOIL that and distribute the 2, you can do all that, but you don't need to. Just look at it. Look at it, right, Peyton? You got the answer, right? Look at it. Stare at it. What will make the inside equal to 0? What will make the parenthesis equal to 0? It's between 0 and 2.
1.
Yes. 1, you got it. Look, right here, 1 minus 1 is what? 1 minus 1 is 0. And if that whole thing's 0, then that whole left-hand side becomes what? 0. Okay? So that is your x-intercept is not 0, but it is 1. 1. You could divide by 2 and FOIL and do all that and get to that, but this is one where it's pretty, if you recognize that, it's just 1 for that case. So that is your x-intercept. Put a dot there. 1, 0. Boom, right there. All right. Josh, how do I find the y-intercept?
Let x equal 0.
Let x equals 0. Have you done that yet?
Not yet. No.
All right. So, does anybody have the y-intercept? What do you got, Emily? Oh,
Negative 2/3.
negative 2/3, you agree? A huge thing is you gotta make sure that sign, if you get the sign wrong, or if things start looking crazy, you probably got a sign wrong or input something. All right, I gotta do a little XY table. And I gotta pick points here, between and beyond. Now, theoretically, this y-intercept kind of gives us what we need, but I still want another point in there just to validate what's going on. So I gotta have 4 points. So tomorrow, you gotta have the number of points. You cannot count your y-intercept as one of the points you plug in. All right, Grace, in that yellow zone, just give me a point to plug in.
-3.
So she says -3. All right, now, all right, right here. What can I plug in that other place? So I'm gonna plug in -1/2. And you might have to plug in a fraction. I know that's not fun, but you can. I'm gonna plug in 2, 1, 2, 3. I'm gonna plug in 4. All right, split up the work. When you plug in 2 of them, the other one plug in 2 of them. These get a little bit, they're not really nice numbers, but you guys can do it.
Well, yeah.
Fine.
driveway?
Dedicate the school to them.
Oh, you?
Yeah. Like that, I guess. Yeah.
What do we get for, -1.5? We got that? What do you got there?
I got -4.5 over 2.25.
Whoa, -4.5 over 2.25. I got -18/7. That's the same thing?
Possibly.
What decimal we get? Did I do it wrong?
That's what I got.
What'd you get?
-18/7.
-18/7. And so that's what, 2 4/7? So -2 4/7. Can we go with that? All right, we're going with that? Going, gone. All right. Luke, what'd you get for any of these?
For 2, I got 2 over -3, I think.
So can I call it -2/3 maybe?
Yeah.
2 over -3. Maggie Purdy, you got -3 or 4?
For -3, I got 32 over 12.
32 over 12, which reduces to, I think, 8/3. Is that 2 2/3? 2 2/3. Ryan, how about 4? You got that one?
No.
No? Anybody else? Cole? You got 4?
3.6.
Ooh, we got any confirmation on that one?
I got
Same thing? Yep. 3.6? Okay, 1, 2, 3. Okay, so -3, 2 2/3 is up here. -1/2, -2 4/7. 2 and -2/3. And then 4 and then 3.6. Okay, all right, from those 1, 2, 3, 4, 6 measly points, we know what it looks like, right? Maybe. All right, and this little point here to the left, this is the only thing that can be happening. It cannot come down and hit that x-axis at all. This little point to the right, this is the only thing that can be happening. All right, what's going on here? So it doesn't go above the x-axis. It comes up and it hits, and then it just loops right back down. Okay, so that's what's happening there. Domain, everything but -1 and 3. So -infinity to -1, union. 1 to 3, union. 3 to infinity. All right, range, look at it. Okay, look at the range. -infinity to 0, then it stops. It includes 0, and then union, it picks that back up at 2 to infinity. Okay, we good on those then? Hopefully. All right, if you're good there, take a look at that next one down below there. Come up, figure out the equation. The dotted lines are the asymptotes. Make sure you identify where the x and y axes are. Sometimes it's easy to get mixed up when you draw on the asymptotes on that one. It's hard to keep it separate. And it looks like that, the red, it's a little bit easier when you look up here. This is -4, 0. This is 0, 0. Okay, and it hits at x equals 2, and this would be y equals 2 for that. All right, take a second so you can figure out what that would be. All right, Gavin, what you got for us? Just any piece that you know.
In the numerator, there actually is x minus 2 because the vertical asymptote is at 2.
In the numerator?
Denominator.
Denominator. Gotta have an x minus 2. Gotta have an x minus 2. What else we got running around there? Jacob, you know anything?
The numerator has to have a x plus 4.
X plus 4, because for each x-intercept. All right, you got one there, but what about this 0 there? What's that? So that's gonna show up in the numerator too, is what?
I said it was a 2x.
A 2x? Let me just put the x for now. I see where you're getting the 2, but let me come back to that. So you got an x for the 0, and you got an x plus 4. All right, since the vertical asymptote or horizontal asymptote's at y equals 2, that means the degrees of the numerator and denominator are what? The same. Are they the same right now? What can I do to make them the same and not add in another vertical asymptote? Okay, Cooper?
Believe I did it wrong, so never mind.
Oh, we got to never mind. What can I do right now that they're different degrees? What can I do to make them the same? Okay, do this. All you can do is just put a squared on that x minus 2. Make it quantity squared. Now, as it looks, what would be the horizontal asymptote? As it looks, it would be a what? 1, we want it to be a 2, that's why Jacob put a 2 in front of that. So 2x times x plus 4 over x minus 2 squared. Okay, all right, and let's just get this last one. Find the horizontal asymptote, or find where it intersects the horizontal asymptote. The horizontal asymptote will be y equals 2. All right, we did one like this in our notes. What do I got to do for figure this one out? Find x. Okay, Tyler.
You set it all equal to 2.
Good. You set it all equal to the horizontal asymptote, which is 2. So 2x squared plus 4 over x squared minus 3x minus 10 equals 2. And you go ahead, and I'm going to get rid of the denominator or cross multiply, however you want to word it, and get rid of x squared minus 3x minus 10. And those cancel, leaves me 2x squared plus 4. Distribute the 2. Two x squareds add up to 0. And I get 4 equals negative 6x minus 20. Add 20. And I get 24 equals negative 6x divided by negative 6. X equals negative 4. So the point would be negative 4, 2. Negative 4, 2. Whew. Got done. Okay, tomorrow, no calculator part. I'll let you use the red ones. Okay, and then Wednesday's the calculator part. Tomorrow might be a little bit longer in terms of time. Make sure you get in here and get working. Okay, especially if you make some mistakes on there, you lose a little bit of time.
Got it, you're gonna get it all done during the first day. If you're just gonna have.
Hey, look, I take both from the same.
No, you cannot.
Not even a conversation at all.
Actually, you didn't take it away.